And as a way of warming up, what I thought I might do is I might harken back to our last lesson and just give you guys an opportunity to practice a little bit. So as I say here on the screen, I want you to, we're going to take 5 minutes. I don't care if you get 0 of them right, okay? For 5 minutes, we're going to chew, what is this, 8 of them? We're going to chew on 8 factoring questions. Some of you guys, it might not take 5 minutes. You might get them all right. I don't know. But I thought it'd be a good way for us to sort of knock the rust off and say, oh, I remember doing this. Or to say, ooh, I hadn't done this in a minute, and I've kind of forgot. And what we'll do today, after this warm-up, is we'll revisit this notion of factoring, because factoring is to write something as a product, Good. So for example, what we're going to be looking for in problems like these, and I hope you guys can y'all see those in the back? Luke, y'all can't zoom. Quentin, I'll zoom in on these first 6 then. What you're going to be doing is you're going to be writing them as a product. So oftentimes it'll look something like that right there, remember? Okay, so I'm going to shut up. I'm going to let you guys work, give you about 5 minutes, and then we'll see if we can get this thing taken care of. Remember, how do I go about checking my work on these, by the way? Yeah, very good. If you want to check to see if your answer is legit, then FOIL it back out. And on these, like, there is a technique, there is a method for them, but remember, if you want to kind of brute force it, you can just start putting together a bunch of FOIL problems and then multiply them together and see if you get close to your answer. And then the closer you get, the more you're like, oh, okay, I know what I need to do here. So we're unfoiling on these factoring problems. And again, don't be disheartened if you're stuck. I'll help you get unstuck. And you should, on these, you should probably be able to get half of your answer just by looking at the quadratic term of each one of them. Like x squared, obviously it's going to be x times x, isn't it? Okay, whether it comes at the beginning or it comes at the end, that quadratic term should definitely be the part that you get taken care of. Mossy, I think your mother had emailed me and said you guys got to do a little traveling out of town. Where'd y'all get to go for your break? Oh, shoot, I still can't hear you guys. Lewis, can I hear you? I swear I thought I heard somebody a minute ago say something.
Hello?
Okay, I can hear Lewis. No, I can't still. Mossy, I still can't hear you. Sorry, bro. We'll get it figured out. You guys have the first 3 written down yet? Can I go ahead and scooch it on down to where y'all can see the last 2, just in case anybody's working ahead? The last 2 just have a couple curveballs that we wrinkle in there. Not anything super hot and heavy, but just like if you're feeling pretty with it, then you can check these last 2 out. And I just pulled these straight from a textbook, like I used to before the pandemic or whatever. I would give pencil and paper homework, and so like these were just example problems from the homework. take about another minute, minute and a half, and wrap these up. And even if you didn't finish them all, we'll get it squared away. Jack? Yeah, absolutely, absolutely. George, he's getting all up in your grill over there, isn't he? Why don't you ask George to do it for you there, Jack? I reckon I'll have to bring my electric pencil sharpener from home and set it up here somewhere. Thank you, George. I like how I'm noticing a couple of you guys are flipping back through your notes. That's an excellent thing to do. And, you know, if you're taking diligent notes, which, again, I'm pushing you guys every day to make sure you're being a good note taker, what you'll do is you'll have examples just like this. They need to be easily findable, right? So in my notes, if I've just got them all thrown in there, all nimbly-bimbly like, then I might not be able to find them quickly. But if I know, ooh, hey, factoring examples, there's a trinomial, you know, method number 4 or whatever method we're on, then I know where to find that in my notes. That's a good thing. Mossy, I saw your comment, so that's cool. I'm glad y'all had a good trip down to see your grandparents. All right, 30 more seconds. And time. All right. Now, what we're going to do is take these one by one. And like I said, if you got them, that's great. If not, then let's just play a little catch up. Again, this is a sort of a warm up / review of some stuff that we did back in December. Now, December might feel like a million years ago, and it might be like kind of blurry since y'all had other exams you were prepping for, and things were going pretty quickly back then. So what we'll do is we'll just take these one at a time. We'll look through and we'll see what to do on each of them. Let me get my little ribbon pinned up here, and then we're going to start it off here with kind of an easy one. Okay, so I know that, like I said, this is going to be a binomial squared. So a binomial time, or not binomial squared, excuse me, binomial times another binomial. And the first term is going to be y times itself. That's y times y. First times first, remember FOIL, F-O-I-L. The first term of each binomial multiplies together to give me that y squared. So that's the only way that I'm going to have a y squared. Okay. A little bit later on, we'll see some examples, and in fact, you guys didn't work any of these, but like you'll see examples like the number 100 right down there at the bottom. Okay, where it's something other than x squared. That's when we start adding in a little bit of wrinkle. Well, should it be 1x and 5x, or should it be 5x and 1x, or who knows? But we'll get to that later on, probably tomorrow. For this one, we know it's going to be y times y. Then I'm looking at 6, and I'm trying to find 2 factors of 6 that add up to -5. Okay? What are those 2 factors of 6 that add up to -5? -2 and -3. So I'd say -2 there, -3 there, or vice versa. The order there doesn't matter because multiplication is commutative. And again, if you want, you can make yourself a factor list. 1 times 6 and 2 times 3. We note the sign in the middle right there is going to tell me, oh, I want both of those to be negative. And there's my outer and my inner. When I multiply the outer, I get -3y. The inner, I get -2y. That combines right there to give us that oi. And then, of course, the -2 times the -3 is going to give us our last right there to complete that FOIL problem. Okay. Any questions on that first one? As it kind of we get back into the swing of things? Anything you wanted to ask about how it worked? Remember, you're unfoiling. Just give me a thumbs up if you figured that one out. Anybody get that one right? Okay, several of you guys. Okay. All right, now the second one, just I'm a stickler for habits, good habits, and I always just rewrite the order of this one. Okay, I always say, you know what, addition is commutative, so I'm going to write this as x squared minus 6x plus 8. Then it becomes a problem just like the previous one, right? Sometimes students forget you can do that, and then they get all confused because of the 8 at the beginning, and they don't know what to do. Now, technically, you could have said, let's just put the x at the end, right? And then figure out two factors of 8 that add up to -6, which are -4 and -2. And you could have written it out that way. To me, that just looks kind of goofy, doesn't it? Having a negative up front, that's unnecessary. We split it up this way, or order it rather this way, and I can say, oh, that's easy enough. X minus 4 and x minus 2. Okay, again, doing the FOIL backwards, just unfoiling that problem. Because -4 times -2 is 8, and -4x plus -2x is -6x. Okay. Can we do the same thing on 78? Reorder the terms. All right. If you didn't catch that little trick, why don't you quickly try and do that then? Reorder the terms just like this: minus 10x minus 11. And I'll go ahead and tell you, in this case, since it's a -11, look at that. I know that the sign of my binomials, the signs are going to be different. One of them is going to be positive, and one of them is going to be negative, because I got to get that 11 that way. Okay. Now, which one do you think Joe's going to be positive, and which one's going to be negative from the factors of 11, which is prime? Do we want a positive 11 and a -1, or do we want a -11 and a positive 1? Knowing that our goal is to have -10 as the sum. What do you think? Will it be x plus 11 and x minus 1, or will it be x plus 1 and x minus 11? Which one of those, test your outer and your inner, which one of those is going to give you the -10x that you want? Yeah, the one with the -11, this second one right here. You guys see what I did there? I did a little brute force. What do I mean by brute force? Well, I just wrote out all of the possibilities, and then we foiled, and we said, okay, well, which one's going to get it done? Okay, so George, what would the answer, or rather, what would the question look like if this had been our answer? We'll go a little Jeopardy style. Here's the answer. What would my question have looked like? What would be different about it? It would 11 times -1, so that won't change. So you're right, x squared's good. Our 11 will be positive, or excuse me, would still be negative, but the 10 would be positive, because do your outer, you got -1x. Do the inner, you got positive 11x. So we got -1 plus 11, so that would change that. If this were going to be, I'll circle it in orange, if this were going to be my answer right there, then this would have to be a positive 10x. You guys understand that? Okay, so that's how our answer would differ just a little bit. Okay, now let's get into the second section right here. Does anybody remember my little trick that I do when they're, oh, Quentin, you had a question, go ahead. It is this answer right here that's on your screen. Oops, I deleted the wrong thing. 11, and let's see if we can scoot this up here. Yeah, that's your answer right there. Say that one more time. So if you didn't hear his question, he was saying, why is the -11? Because it was negative to start with. When we reordered our terms, we wanted to maintain the signage of each of those terms. Good question, Quentin, and good question, Paul. Thank you. Anybody else with questions on those? Okay. Y'all finding this a little helpful, maybe to get the ball rolling again? I did not want to jump in just hot and heavy on like a brand new factoring technique just yet. We got to kind of make sure we're firm on our footing. 81's got a little bit of a wrinkle. Anybody remember what I suggested we do when there's multiple variables in a problem? What can you do temporarily to make it a little easier on yourself? Again, I like how I'm seeing a couple of you guys looking back in your notes. We said you could ignore the second variable temporarily. Just like pretend that it's not there. So what would I want to pretend that number 81 looks like? I would just want to say, all right, that's m squared minus 64m minus 65. And just temporarily, I'm going to pretend like that's what the problem is. Okay? Now, can anybody come up with a couple factors of negative 65 that add up to negative 64? Since 64 is close to 65, it's probably going to be 1 and 65, but how do I get my signs squared up? James, what do you think? Yeah, good. So m minus 65 and m plus 1, right? That's how that one would work out. You get tested by foiling. You know, you do your outer and your inner, and you get negative 64m. And then the trick here is just say, oh, well, you know what? Since there's that extra variable there, since there's that extra variable of n, let me just put that at the end. And again, check it and it foils. What's negative 65n times positive 1n? That's going to give me negative 65n squared. And then when we do the outer and the inner, oops. When we do the outer and the inner, we get that negative 64mn term as well, okay? So if there's two variables, I would make a note to that effect, by the way. You guys take good notes today. We don't just have, you know, just this comment once in class and then we're allowed to forget it. If there's multiple variables, just temporarily ignore the second one. That's how we're going to work out 84 and 87, okay? Is anybody getting hot in here? I cranked the heat up. I'm sweating bullets up here. Goodness gracious. Y'all okay? Y'all happy with the temp? I know I got my window open. All right, let's see if we can look at this 84, this next one, okay? I'm going to temporarily ignore that S. So I'm just going to scratch it out. Get it out of here. Get on out of here, S. And we got negative 28. Now use your eyes, and you guys tell me, what is a pair of factors, negative 28, that add up to positive 3? Think about it. If you've got that answer already, that's great. Okay. Actually, I saw your hand first. Go ahead. 7 and negative 4. Benton, is that what you got? Okay, good. 7 and negative 4. So I'm going to say R plus 7 and R minus 4. We'll do a real quick FOIL check in my head, right? You guys know that we can FOIL in our head. R times R, that's money. 7 times negative 4. Once again, that's great. And then the outer would be negative 4R. The inner would be positive 7R. And that's going to give me a positive 3. And then what's my last thing to do, Luke? Yeah, just slap that bad boy back in there. Put that S in there, right there, and right there, and that's easy money. Okay. Quentin. Great question. The reason that our answer doesn't have an n squared is because when I got too many colors here. Hold on a second. We'll write this up in just in blue. There we go. All right. So we had mn 65n squared n. And I love how you guys are asking these questions, by the way. Y'all keep them coming. All right, the reason that we don't have an n squared in our answer is because when you FOIL that back out, you're testing, you're multiplying that last term times that last term. That's where you're going to get your n squared. Because I got negative 6 times, why the dump did I write a 1 there? What was it? Y'all help me out. It is supposed to be 60 minus 65 then. That's what it was. When my eraser came through there, it was a little bit, it erased too much. There we go. All right, now we're good. So Quentin, when you multiply that last times that last, the n times the n, that's where you're going to get your n squared. Okay. And the reason that the middle term is able to stay as an mn term and it's not squared is because when I multiply the outer two, I'm getting 1 mn, and the inner two, I'm getting negative 65 mn. Okay. There's no exponents being used there. Okay. All right, 87. Again, second variable, we can ignore it. So what are two factors of 30, Nate, that add up to negative 5? What do you think? You want to help make me a factor tree real quick? Let's do a factor tree. So you got 1 times 30, 2 times 15, 3 times 10, 4 doesn't go in, 5 times 6. Now that's a positive 30 and it's a negative 5. So if we were going to pair them up, we would want all the negatives. So you guys tell me which of those pairs adds up to negative 5? Trick question. None of them. Is that okay? Yeah, what would we write as our answer? Well, it's not an equation to solve, it's an expression. So we would just say does not factor. I know that's kind of tricky. I didn't warn you that that would happen. But now you know that can happen, right? Okay, Tiago, next time we'll be ready. But yeah, not everything factors out nice and neat. Once in a blue moon, you'll get. Now, here's what I don't want to see. Like in years past, I'd give like a test, okay? A factoring test. And let's say I'd give you 20 of these on a factoring test. And some goober would put like on 13 of them, he'd be like, DNF, DNF, DNF. No, okay? It's once in a blue moon. What does that mean, once in a blue moon? Rarely. Do y'all know we had a blue moon this past year in 2020? Do you know what day it occurred on? Halloween. Isn't that the craziest thing? See, I'm getting cold up here now that the heat turned off. It's when you have 2 full moons in 1 month. That's called a blue moon. And it occurs very infrequently. It's also a great song by Toby Keith, one of country music's former bad boys of country music. You know who Toby Keith was? He went on WWE or WWF or whatever the wrestling show was back then, and he wrestled Dennis Rodman. Y'all know who Dennis Rodman is? Okay. So a country music singer and a basketball star wrestling each other on TV. It was kind of madness. But all right. Anyway, number 87 doesn't factor. And then I think maybe these were our last two. Is that right? Okay. These have a little bit more than just a wrinkle. Okay. These have a little bit of an extra kick to you. The first thing that we always check for when it's a factoring problem is what? What was the very first factoring technique that you guys learned from me? 3 letters. GCF. Write that down then. Because not everybody just jumped out of their seat and said, oh, I know, it's the GCF. I always check for that. No, this is our bread and butter factoring technique numero uno. Right? Remember we talked about bread and butter, Andrew? That's what we have at every meal, right? Unless you're like on a keto diet or something, in which case you skip that. But no. When we talk about this factoring technique, it's what we always look for right out of the gate. Okay? Lewis, what is 3m cubed, 21m squared, and 30m? What do all 3 of those terms have in common?
M.
What else?
3.
So our GCF, he just very quickly, just using inspection, he found it to be what?
3M.
3M. So that's what I'm going to take out first. I'm going to take out a 3M, and then what I get on the inside is leftover. How do I go about finding the leftovers? What do you think? If I took out a 3M, what's going to be left over here? Attaboy. So we're doing this mental division, aren't we? Okay. We're doing this mental division. Grove, take it over from there. We got m squared. What else? Divide 21 by 3m. 21m squared by 3m. 7m. Good, because we're just dropping one of the m's each time. And then last but not least, Reed, what's my last term? Yeah, just 10, because we took out the 3 and we took out the m. You're mentally dividing each term by that GCF, right? And then look what's in the parentheses. We don't want to stop now because it wasn't just a one and done factoring technique, was it? Okay. So what are 2 factors of 10 that add up to -7? Yeah, 5 and 2, and we'll make them negative. So we're going to say 3m, and we got m minus 5 and m minus 2. And that's going to be our answer right there. And again, how would I check it? I'd FOIL and then distribute the 3m back in. You're just, factoring works one direction, and then checking your answer is just multiplying. You're working it backwards in the reverse direction. All right. Now that one's not a tough one now that you know the little trick, right? Now that you know to look for the GCF. So who can find the GCF formula on 94? Okay, Paul, go ahead. 6y squared. Good. 6y squared. Let's take that out. Let's mentally divide that away. Here, we'll do it down here. We're going to take out 6y squared. Okay, Luke, what's left over in your first term? You took out a 6. It gone. So just y squared. Okay. What do we have, Alex, from the second term? Mentally dividing it by 6y squared. Good. 6y squared. So we got 2y. And then let's see here. Go ahead, Joey. What's my last term? Divide 6y squared. What kind of 8? Attaboy, 6y squared. Because the y squareds go away. And so I'm just left with -8. Now, do I stop there after I took out the GCF? Heck no. Okay, I finished that up by saying, beard stroke. What factors of -8 do I know add up to +2? Yeah, -4, +2. Now you guys are getting a little quicker. You get a little bit better, which shows me that we remember this technique for basic trinomials. What'd you say? +4 and -2, and I can check my work. Right? I can check my work by foiling it out. We needed a little bit of review because we hadn't done this in a while. You guys haven't gotten to factoring yet in your 8th grade classes at your middle schools, is that right? You probably will within the next couple months. And so when we go through and we talk about factoring, it's to write it as a product. And what we want to do is we want to write it as a product of fully factored out factors, fully broken down factors. Like, yes, we wrote this on that first step as 6y squared times that trinomial. So technically we factored it. But to factor something, quote, completely is our goal. Can I break down y plus 4 any further? No. Can I break down y minus 2 any further? No. So that's factoring completely, okay? And so we'll continue on tomorrow. We'll teach you a new technique tomorrow. This was review stuff. But we'll learn a new technique tomorrow for factoring problems like number 100. So that's where kind of the path that we're taking, and you guys will figure it out pretty well. All right, any questions before you dismiss? I'm so glad you guys are back. I've been missing you. Have a wonderful day. You boys at home, be safe and healthy and happy, and everybody live Jesus in their hearts. All right, thank you so much. Y'all have a great one. Y'all were my only class to teach today. Can you believe that? All right. Y'all be safe.